Hello, welcome to Turner Sensei's Math 7 videos. Today we'll be discussing exponents in scientific notation. So previously we talked about powers of 10 and how those get increasingly large and give us decimal places and place values in our digits. So today we're going to be looking at how we can use that to work with very large numbers. So for an example, we're going to start with a light year. 1 light year is 5,878,000,000,000 miles. This has way too many zeros to work with in an easy way. So we rewrite it using powers of 10. If we look here, we can take this 5878 and multiply it by, from last time we know that each place value is 1 power of 10, so we go times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 5,878 times 10 to the 9th. So this is the only way that we could write it, though. You're probably guessing that the answer is no. So we can write it in several different ways. We could keep on adding powers of 10. If we did times 10 to the 11th. We'd start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places. So this would be 58.78 times 10 to the 11th. Or we could even go up to 10 to the 12th and do 5.878 times 10 to the 12th. For each of these, we notice that even though we have written it differently, these all mean the same thing. These are all equal. So if we look, how can we get a standard way of doing these? The answer that scientists came up with, because scientists, particularly physicists and chemists, who have to deal with very large numbers all the time, decided to create a standard for scientific notation. So the rule that we follow for scientific notation is this. We have to make sure that our number to the left of the times 10 to whichever power we choose, we have to make sure that that number is between 1 and 10. So it has to be 1 or greater, and it also has to be less than 10. So the number at left is between 1 and 10. And more commonly, the way that we think about it is, rather than thinking, oh, is this number between 1 and 10, we look at the decimal place. So if we look at it from the perspective of the decimal place, we want to have one non-zero digit to the left of the decimal place. So to repeat, that is one non-zero digit to the left of the decimal place. So if we look back at the 3 ways we had of writing this very large number, how many miles are in a light year, this one is too large. It is way bigger than 10. So that one is not proper scientific notation. This one here, while smaller, is still bigger than 10. So that is also not proper scientific notation. You notice we have 2 digits to the left of the decimal place. Our one that actually fits for scientific notation is right here. We have 1 decimal point to the left of the decimal place. We have 1 digit to the left of the decimal place, pardon me. So we have 1 digit to the left of the decimal place, which means that this is in the proper form for scientific notation. Now, we can write numbers that are in scientific notation in standard form, and we can write numbers that are in standard form in scientific notation, and we can also use scientific notation to compare very large numbers. So we're going to start off with a little bit of work converting from scientific notation into standard form. Alright, now we're going to look at an example of rewriting scientific notation into standard form. So we have a process with three things to keep in mind as we go along. The first is when we are changing, we need to, before we do anything else, move the decimal point to the right. So with this problem, where we have 3.04 times 10 to the 7th, our first two steps are going to be moving this decimal point right once and twice. So I'm going to rewrite this down below with that decimal point moved. So we have 304. Next we need to add zeros. But we need to be very careful at this third note. We do this only as many times as we have a power of 10. So we start off by moving the decimal place twice. That takes care of two of our powers of 10. So we go 2, 3, 4, 5, 6, 7. And we have now the number rewritten in standard form. And it's a little bit difficult to see what exactly this means when we have a long string of zeros. So let's put in the commas to tell where our thousands are. So if we look, we've got our thousands and our millions here. So this is 30 million and 400,000. So again, we need to either move the decimal point or add zeros in a combination that adds up to this number here. So we moved the decimal twice and added 5 zeros for a total of 10 to the 7th. If this is a little bit confusing, the moving zeros idea, the other way we can think about it is by multiplying this number by the expanded form of this number. So I'm going to put this up as an alternate way of doing this. So instead of writing it like this, we're still going to do 3.04, but we're going to do this times 10 to the 7th. So this is going to be 1 with 7 zeros after it. This is going to be 3.04 times 10 million. If we multiply that out, we're going to find that, I'll set up the long multiplication here, we have to put in 7 placeholder zeros, and 1 times 3.04 is going to be 304. When we do our last step, we have to keep track of our decimal. So we put our decimal here, and we find that just as before, our answer in standard form is 30,400,000. So you can either rewrite it by moving the decimal place and adding zeros, or by doing this multiplication. Moving the decimal point and adding zeros is a shortcut for multiplying by large powers of 10. Now that we've done a little bit of work with rewriting in standard form from scientific notation, we're going to go backwards. We're going to go from standard form back into scientific notation. And the way that we do this, we just reverse the entire process. So instead of moving the decimal to the right, based on something that starts off as a decimal, and then adding zeros, we're going to be moving this decimal point over and taking away zeros. So if we look here, you're going to see that there isn't a decimal point right now. Remember that every whole number has an implied decimal point right at the very end. So we're going to do a two-step process. First, we're going to move the decimal point so that there's only one digit on the left. So we go 1, 2, 3, 4, 5, 6 spaces. And now, we rewrite this so that we have a power of 10 that's equal to the number of times we moved that decimal point. So since we moved that 1, 2, 3, 4, 5, 6 decimal places, we're going to have this be 5.97 times 10 to the 6th. So I'm going to leave this up and step aside so you can pause and copy that if you need to, and then we'll move on. The last skill that we'll practice today is comparing numbers that are written in scientific notation. So we have a two-step process for this one. First, we check the power of 10. The number that has the larger power of 10 is going to be the larger number. If the powers of 10 happen to be the same, that's when we go on to the next step. So if the powers are the same, we have to compare the numbers in front of that power. So let's take a look at an example here. We need to arrange these three numbers in order from least to greatest. So we'll start off and we'll compare these two numbers, 4.7 times 10 to the 9th and 2.5 times 10 to the 9th. First step is we look at the powers. These are both to the 9th power, so we have to move on to the second step. Since those powers are equal, we need to compare the numbers. 4.7 is bigger than 2.5, so I'm going to write this right now with 2.5 times 10 to the 9th is less than 4.7 times 10 to the 9th. Alright, let's now check the last number here, 3.9 times 10 to the 7th. If we look, we can compare this 7th power to both of these 9th powers, and we know that both of these numbers are bigger than this one. We don't have to compare the numbers in front, we are only comparing the powers of 10. So to get our final answer here, we're going to rewrite this. So the order from least to greatest is 3.9 times 10 to the 7th is the smallest of the three, 2.5 times 10 to the 9th is the middle, and then 4.7 times 10 to the 9th is the largest of the three. Students, please remember to fill out your notes and have those ready to be checked off in our next class session. If you have any questions, please ask them in the comments section below or email me directly. Parents, teachers, and administrators, if you're looking to use these videos, there is curriculum alignment information below as well as links to additional resources. Thank you for watching.